So our song for this video is Head Over Heels by Tears for Fears. Alright, we're going to take a look at all sorts of types of linear functions in this section, which you, again, should be familiar with. Most of this unit is some review. So we're going to look at determining whether or not a function is linear, and then being able to graph several different types of linear functions. Lots of vocab, but all of this you should be familiar with. If you feel like it is information that you know, don't feel like you have to write it down just because it's in my notes. This is reviewing information you should already know. So if there's any of it that you're like, oh yeah, I forgot about that, maybe you should jot that down. So our first is, what is the definition of a function? A relation is any pairing between any two numbers. A relation is a function if the x value, or the independent variable, is paired with no more than one y value, or dependent variable. A linear function is a function with a constant rate of change. Typically, we'll see our slope-intercept form, which I'm sure you guys are very familiar with, y equals mx plus b. And of course, when you graph a linear function, it looks like a line. But the key here is a constant rate of change, because there are many different ways to see a linear function. So we need to look for that constant rate of change. Slope is another word for rate of change. You can also take a look at that as rise over run. If you're not familiar with these symbols, this is the Greek letter delta, and it means change. Change in y over change in x, or our common slope formula of y2 minus y1 over x2 minus x1. X and y intercepts are where the graph crosses the x and y axis respectively. When you're looking at the x-intercept, the y value is 0 when you are on the x-axis, and vice versa for our y-intercept, your x value will be 0. So the first thing we're going to do is determine if the function is linear. So remember, when we are looking for a linear function, we are going to look for the rate of change. Is the rate of change constant? And it's change in y over change in x. So I'm going to look at the change in my y, and then the change in x. So my rate of change is -1/2, -1/2, -1/2. So my rate of change is constant. Therefore, this function is linear. Now the next representation we have is a mapping. And this mapping is a little bit challenging to read because my x and y's aren't paired straight across from one another. So instead of trying to figure out my rate of change from this, I'm going to go ahead and put it in a table, making sure to match the appropriate x and y's with each other. So my x's, I had 2, 3, 4, 5. My x value of 2 mapped to a y value of 2. My x value of 3 mapped to 4. 4 mapped to 8. And my 5 was a little bit more straightforward, mapping to 16. So looking at my change in y, I've got a +2, +4, +8. Now this doesn't mean that our rate of change isn't constant. We also have to take a look at our change in x. Now because my change in x is constant, I have a rate of change of 2, rate of change of 4, and a rate of change of 8, which is not constant, so this is not linear. And our first type of graphing is going to be using intercepts. So think about if you are on the x-axis, as we talked about with the vocab, your y value is 0. You're moving left to right, but you are not moving up and down. So when we solve for the x-intercept, we substitute 0 for y. So of course that cancels, leaving me with 4x equals 16. Dividing both sides by 4, I get an x-intercept of 4, 0. Make sure you write that as an ordered pair for me. And thinking about our y-intercept, if we are on the y-axis, we moved left or right 0, but we did move up or down, so our x value is 0. So to solve for the y-intercept, we'll substitute 0 for x. Again, that term will cancel. Don't forget not to cancel the negative in front of your 2. That does not cancel with 4 times 0. So I'm going to divide both sides by -2, giving me a y value of -8, or a coordinate of 0, -8. So now you guys will get to see my fantastic line drawing skills. So we plot our intercepts, and then we attempt to make a straight line between the 2 of them, but my lines tend to end up a little bit more curvy. That's actually not too bad.